Good to see you. What are we doing? Today we're doing system of equations. These can be fun. Hello. Okay, so for the few people that are here, the homework that's given today is going to be the homework for today, tomorrow, and Thursday. So you really have 3 days to do it, but honestly, you have till Friday to get it done. So I'm telling you that ahead of time because I don't think I'm going to assign anything else in math for you to do other than that. I also do not want to go over those until Thursday. So if you're asking about them, I want you to try them on your own first, and not try them with me first. So I don't want to answer any questions specifically on, hey, how do I do this problem? Because it's probably to a point where, hey, we'll deal with problems similar to that later on, or I want you to just try it on your own first. And some of them are not in the form of y equals mx plus b, so it is going to take some moving things around in order for you to actually solve them. Yeah, I'll be live streaming tomorrow, I'll be live streaming Thursday, and I'll be live streaming Friday. So if you do have questions on them, they will eventually get answered. I just don't want to answer it today. I want you to sit there and try them on your own, get things wrong, and then see why they're wrong for that. When it comes to science, I just unlocked Chapter 7. Chapter 7, which I want to say is Chapter 5 in the book. I'm not sure. Read the website so you know what's going on. For science, Chapter 7, you owe me key terms, section assessments, one project that you don't, well, you have choice in it, but it's a report. You're going to do a report on a genetic disorder. So what I want you to do is I want you to choose a genetic disorder, a disorder that has predisposition through genetics. I want you to tell me what your disorder is so I can actually say, yes, that's an acceptable disorder, or no, that's a not acceptable disorder, because it would be a real shame if you did your whole thing on something that did not fit the criteria and then wouldn't receive credit for it. So make sure you confirm your topic with me. Just shoot me an email saying, hey, I'd like to do this genetic disorder or that genetic disorder or whatever. As long as it's genetic disorder, I'll probably say yes. There are a few that I probably will say no on just because of controversial topics around it or something like that. So once you decide on your disorder, send me and say, hey, I'd like to do this disorder. And I'm going to have you do that in a slideshow. So I would like you to make a slideshow about it. And again, you can go in pretty in depth on some of these disorders, so please do so. I will not be testing you on Chapter 7, and I will not be giving you quizzes. I will not, I mean, this is it. I want you to do key terms, I want you to do section assessments, and I want you to do that project. So take a week to watch the videos and do key terms, take another week to do section assessments, and last week to do your final project. And I would like this due May 25th. That way I can get everything graded by the 29th. So if you turn it in later than the 25th, I cannot guarantee you that I'm going to get it graded, and therefore it'll be on your report card. So make sure you get it in by May 25th. And videos are unlocked for it. All this information is in the attached assignment sheet as well at the end of the chapter. And again, if you have questions on things, shoot me an email. Make sure you get this okayed by me. I don't want you picking something that has a very loose genetic tie, such as, like, I don't know, heart disease or something, because it's not really that great of a disorder. I mean, some people might classify it as a disorder, but it's really more of a illness or disease. So just that stuff. Yeah, for chapter 7, yeah, you don't have a lot of time. That's why. I hope you're done by May 25th. But honestly, once you get it done, I want to say this is chapter 5 in the book. It is human inheritance. So key terms, section assessments, watch the video, and then slideshow on a genetic disorder. I mean, some people are still working on chapter 6, so I don't want to have people not have time to do assignments. So I'm giving it to you now. That's it for science. Once you get that done, you're done with science for me. Unless you really want me to give you more science stuff. I have more science stuff that I can throw out at you if you really wanted. Or you can just look at my YouTube channel and watch random science videos each day for science. Just get something. I mean, education can come from a lot of places. So that's what I'm asking. Hopefully you finish your science test for chapter 6. Got that in. I will start checking chapter 6 stuff this weekend. If you're missing things from chapter 5, make sure you get that in, which if you're watching this, you're probably not missing anything. No, I don't think we have a new name for the school yet. I think it was proposed to the community and like the 8th grade classes to like vote on it, which I'm not sure why it was given to the 8th grade classes, because they wouldn't go to the school. But I thought it's something you're doing in religion class, though, I think. So I'm not sure. I don't have anything to do with naming. I mean, I could like put a vote in if I cared, but I really don't care what the name of the new school is. You might. I was never one to have much school spirit and things. Chapter 5 is modern genetics. Is that it? Maybe chapter 4. What's chapter 4 say? I think it's human inheritance. It might be modern genetics. I have stuff on modern genetics, but I don't think that's the right chapter. Yeah, it is modern genetics. Yes, this is chapter 5. Chapter 5 in the book. The first section is human inheritance. That's why I'm thinking that. So, any other questions before we start the math? Again, the attached sheet is going to be due Friday. You're not getting more assignments Wednesday or Thursday, so it is just the one sheet. They are tough questions. I do not want to answer questions on them today. I can start tomorrow, but you're going to have to look through them, find ones that make sense. Some of them are written in standard form. Some of them are written in point slope form, maybe. Some of them are written in slope intercept form. You only know slope intercept form, so you're going to have to rewrite them in slope intercept form. So do a little bit of algebra to turn those into that, and then you can solve your system of equations. But it is a challenging worksheet. It's going to take you time. Once you get frustrated, be done for the day. Work on some on Wednesday, work on some on Thursday. ask questions, and get it in by Friday. So with that, let's talk system of equations. System of equations is a very powerful algebra tool. It is one that is used all the time. So it is actually very pertinent to what it is. But basically what a system of equation is, a system means that there's multiple equations. In this case, you're going to get two. So we're going to say you're going to have two equations, and you want to find where they intersect. Intersects. I don't know if I spelled that right. Intersects. I don't know where their intersection point is. So where these two equations are going to actually cross. Now you know this for lines, so we know this for lines. We're going to do lines. This is work for other types of equations. If you have trig equations, if you have quadratics, if you have exponentials, it will still work. It's just that we don't know the equations for those. We haven't done any work with those things. We're going to stick with lines. So for our purpose, we're doing lines. Next year, we might get into a little more complex stuff with system of equations. But we're concerned about lines right now. So basically, we're going to have two equations, and we're going to want to know where they intersect. So if you're following along in the notes, this is the first example. So example, I have the equation y equals 2x minus 3, and I have the equation y equals x minus 1. I want to know what solution to these are the same. Where is it that x's will be the same to give you the same y values? So what is the solution for this? What is the x value and what is the y value here on where they intersect? So what is the point they share is what we're really asking for. What point do they share? What point on the graph do they share? And I'm going to show you 3 ways to do this. The first way you do it is by graphing. So you can go ahead and graph these two equations, and I'm going to rewrite them in different colors so we can see what they are. So we have y equals 2x minus 3 in blue, and we have y equals x minus 1 in red. And what we're going to do is we're just going to graph these two equations and see where they actually intersect. That is one way to solve this. I mean, we're trying to find the intersecting points, so let's actually draw them out and see where they intersect. So on your coordinate plane, let's graph these two equations. Let's see. Let's do blue first. When you graph this equation, just like we did yesterday and the day before that, remember, our slope for our blue one, our m, equals 2, and our b value, our y-intercept, is equal to -3. Again, it's coming from here and here. So I know my b value is -3, so down 1, 2, 3. I know this line goes through that point. I know my slope is 2, so that's 2 on the rise, 1 on the run, and it is positive, so I want to make sure my line is positive off of that. So 2 up, 1 over gives me a point there, and again get a couple in there so you can see how it's painting out, and so my ruler can fit. And I'm going to stick my ruler on there and draw it nice and neat. You need to be neat with your graphs. If your graph is not neat, it's not going to be a very good depiction. And it's going to be hard to read. So here's my first equation. Pretty simple. You should know how to graph that by now. You should be fairly good at it. Next, I'm going to graph my other equation. That's in red. So this is y equals x minus 1. And here my slope is the number in front of here, which is actually a 1. So my slope is 1 here. It is positive as well. And my y-intercept is at -1. So find -1. And up 1 over 1, up 1 over 1. You'll see how I wrote on the same dot there. That is our intersecting point. So that is our answer right there. But let's continue to graph it all. And you can see this line is going like this. you can see where they intersect right here. This here is my answer, which is 2, 1. So 2 on the X. I'll do this one in black because it's part of both of them. Not that. So my answer here is 2, 1. This here is the answer to the system of equations. In other words, this is the point they share. So if I plug in this point to both of these equations, I should get the same answer, right? If I plug in to my first equation, if I plug in y equals 2 times x, x is 2, so 2 times 2 minus 3, I get 2 times 2 is 4, 4 minus 3, I get 1. You'll note I get my y value, I get my output. Same thing should happen with the second one. Y equals x minus 2 minus 1, x is 2, 2 minus 1 gives me y equals 1. So again, I'm sorry, it'll be 1 equals y. So you can see that these values both make these statements true. So this is the point they share. That is the solution to the equation that I want. And you can get that by just graphing it and seeing where they intersect. Let's do another one, just to get, again, used to doing them. It comes with practice. And there's a lot of work to these. A lot of time, that's another layer. So keep yourself neat and organized so you can see what's happening to each. Give yourself space to work. And we'll need a coordinate plane. And let's graph the next set, which is y equals 3x plus 4 and y equals 3x minus 1. And I want to know where these two things are going to cross. And we'll see what happens here. We get, let's do the first one in blue, y equals 3x plus 4. Again, my m value here is going to be 3, and my b value here is going to be 4. So m is, my slope is going to be 3 over 1. So it's rise over run, remember, going up. And remember, it's positive, so it better have positive slope. Just double check your slope. Make sure you're doing the right direction there. But b is 4, so we have 4. 1, 2, 3, 4 is right here. And then my slope is 3, so 3 up, down, over 1. 3 up, over 1. And I can go down if I wanted. 3 down, left 1. 3 down, left 1. So this is where my line is looking like. We get a point here. We got a point over there. And there's our blue line. Again, lines have arrows. Are they on forever? Now let's graph the red one. This is y equals 3x minus 1. In this case, m equals 3, same as the other one, so that is 3 over 1. And b here is going to be minus 1, so we go minus 1 down here. Up 3, 1, 2, 3 over 1. Up 3, 1, 2, 3 over 1. Up 3, 1, 2, 3 over 1. And you start getting your line there. And here is your line. And our solution is where these two lines intersect, but these ones don't. These lines are parallel. So if you remember, parallel lines do not intersect. So there is actually no solution here because they don't share any points in common. Again, the system of equation is asking, find where they intersect. What do they have in common? If your lines are parallel, you don't have anything in common. And the dead giveaway for parallel lines. So if you want to write this down somewhere so you remember it. Parallel lines have equal slope. You'll note this slope was 3, this slope was 3. If they have the same steepness, then they're going to be different. But they also need to have different y-intercepts. Because if they had the same intercept, then they would share every point in common because they'd be the same line. So in this case, they are parallel. I know that because they have the same slope and they have different y-intercepts. So even if I were to go and say, hey, can you find y equals x plus 4 and y equals x minus 3, these are also parallel lines because their slope is equal. They both have 1 as a slope, and they have different y-intercepts. This is a positive 4 and this is a negative 3. So these are parallel. There is still no solution to these ones as well. So y-intercept form does help you in system of equations a little bit, figuring out if there's a solution to it or not. Sometimes you don't have a solution. In this case, you don't have one because they are parallel lines. So graphing is one way of solving these. And again, you probably are pretty good with graphing by now, at least I hope you are, from graphing from the slope-intercept form, because it gives you the slope and 1 point, and you can just count by using rise over run. Any questions about graphing? I mean, you really just graph them and find their intersection. That's one way to solve these. This comes to be problematic in certain cases because this is not good with ugly numbers. No number's really ugly, but you know what I mean. Like if you have irrational numbers you're dealing with, those are going to be really tough to graph because you can't graph them. If you have numbers that have repetends in them, those are going to be tough to graph because you can't really graph those very well. And even if you just have really big numbers comparatively, you don't want to sit there and graph really big numbers. So if your numbers are simple and easy like the problems I just showed you, graphing could be a great way of solving these. However, once you get more complicated, it's going to be a lot harder to graph, and let alone you need to make your graph look very neat or accurate. So you need to make accurate graphs, which is tough to do by hand. I mean, I showed you how to do it in Excel, or sorry, Google Sheets, if you would like to use Google Sheets to do them, but it is tough to do by hand. So we can solve these another way, which is by algebra, and this is going to be where things get a little tough. So we can solve them by algebra. And what you're going to need to be able to do for algebra, I'm going to get rid of this part here, I don't need that. To solve things with algebra, you're going to need to do substitution. So let's look at problem number 1 again. Let's bring it back. Where was it? If you remember, y equals 2x minus 3 and y equals x minus 1. I want to say the answer was 2 comma 1, but I'm not 100% sure on that. I don't remember off the top of my head where it was. I can actually check that as 4 minus 3 is 1. Yeah, so this here is the answer. We know that's the answer because we just did it by graphing. So we should be aiming to get 2 comma 1 here as our answer. Just keep that off to the side of our head while we do this algebraically. So there's steps for algebra. So here we're talking about algebra. Let's write our steps. Step 1 is substitution. You want to substitute one equation into another. It does not matter which one you substitute into which, because you're pretty much going to end up getting the same thing. Here, you'll note these things. If y equals 2x minus 3 and y equals x minus 1, therefore, this is our logic symbol for therefore, you know that 2x minus 3, which is equal to y, is also equal to x minus 1 because x minus 1 is also equal to y. So if a equals b and b equals c, then a equals c as well. This is your transitive property. So you can substitute these into each other. And again, we just substituted the y. This equals y, so instead of writing y here, I wrote this. Or vice versa, this equals y, so instead of writing y here, I wrote this. You'll get the same thing. It's just the order of it might be different. Once you have that, you're going to do step 2, which is combine like terms. So I'm looking at this right now. I substituted. Now I'm going to combine like terms, or I'm going to get x's together. You did this last chapter. So we're going to get our x's together. And again, you have an option here, just like you did last chapter. You're going to need to know how to do it always. Hopefully this is pretty easy for you already. This you're going to need to know for sure. I can tell you right now, SAT stuff, this is what's going to be on there. Most of it's going to be algebra and most of it's going to be geometry. This is what you're going to need to know. You want to get your x's together here. So here we want to either move 2x over or 1x over this way. I'm going to move the 1x over, so we're doing this stuff. I'm going to subtract an x from this side, and if I do it on that side, I have to do it on this side as well. So 2x minus x just gives me x minus 3, and that's going to equal -1. And then I'm just going to solve for x. So your third step is to solve for whatever your variable is. And it is going to take practice, so we will do a couple of these together. So we are going to solve for our variable here. Get x by itself. To do that, we're going to add 3 to both sides, plus 3, plus 3. And we're going to get x equals 2. And that makes sense. That's what I want to get. I want to get x equals 2. However, that only tells me my x value. I don't have my y value. 2 is not a point. 2 is just an x value. So I need to take this and plug it back into one of these. So take it and plug it back into one of our originals. So number 4 is to get your other variable. Plug back into one of the original equations. It does not matter which one you plug into. I could plug this into this one, or I could plug it into this one. Either way, I'm going to get the same answer, because that's what the x coordinate that they share is. So this one here is probably easier to plug into. So I'm going to go ahead and plug into that one. So y equals x minus 1 is y equals 2 minus 1, and therefore y equals 1. And that's where I get my 1 value from. So my answer, again, is a point. Your answer is where they intersect, and that's at 2, 1. They intersect at this point here. I think I have some more we can do here. So let's get rid of all of this. And I'll keep our second thing, algebra, over here. And let's look at the example y equals x plus 2 and y equals -2x plus 2. Now right away my slopes are different. So I know these are lines. I know they're different lines because our slopes are different. I know they're going to intersect at some point. There's a solution. They're not parallel and they're not the same line. So I know there is a solution to this just by looking at it and looking at my different slopes. And again, all what you need to do is substitute first. So you're going to substitute one of these into the other. you'll see how they both equal y here. That's a great thing. So I'm going to substitute one into the other. So here we have x plus 2 is also equal to negative 2x plus 2. Again, they both equal y, so therefore they both equal each other. So that's our substitution. Next, we're going to combine our like terms. You can either bring this x over, or you can bring the negative 2x over this way. I'm going to bring the negative 2x over because that's going to be addition. So you can do whatever you want, but I'm going to add 2x to both sides. That's going to give me 3x plus 2 over here, and my negative 2x and my 2x are going to cancel, and I'm going to leave with just 2 over here. So this here is combine like terms. Now I'm going to solve for my unknown. I guess we could have did the line there too, but let's solve for our unknown. Doing our algebra from the chapter before, we're going to subtract 2 from both sides. So minus 2, minus 2. Remember, we do order of operations in reverse, and we're going to do inverses. So if we're adding 2, we're going to subtract 2. So here we get 3x, and then 2 minus 2 is 0. So still have to get x by itself. Yeah, this is what we're doing here. We're going to solve for x. Still have to get x by itself, so I have to divide by 3, and I get x equals 0. This will cancel. 0 divided by 3 is 0. So I know my x value to my term is 0. I do not know my y value. However, it's pretty simple because that's going to be your y-intercept then. And we know our y-intercept here is both positive 2. But we can plug into here to find that out if you didn't catch that. So when we plug in, it doesn't matter which one you choose, you're going to get the same result either way. That's why we're using 0 for x. We want to know where they share the point. We know the x coordinate is 0. So we're going to plug in 0 from one of these. This one is probably easier. And you get y equals 0 plus 2. So y equals 2 here. So this here is the point they share. And you can go ahead and graph that if you want to double check it. But that is the point that they share. Let's see. Let's do one that's parallel so you can see what happens. So our next one, let's bring back y equals 3x plus 4 and y equals 3x minus 1. These are same slope, different y-intercepts. These are parallel lines. So they should have no solution to them, because they're not going to intersect at any point. So let's do it algebraically and see what happens when there really is no solution to things. So again, we're going to substitute one into the other, and we're going to see what goes on here. So here we get 3x plus 4 is equal to 3x minus 1. And get our 3's together, or our x's together. I'm going to subtract 3x here, and I'm going to subtract 3x here. In this case, you're going to get those x's are going to cancel, right? Those cancel, those cancel. Here you're going to get 4 equals negative 1, which doesn't make sense. And that's your telltale sign that, hey, there is no real solution to this. 4 does not equal negative 1. These do not have a point that they share. And therefore, this can't actually be a system of equations with an answer, and therefore it's going to be no solution. So if this does happen to you, it's no solution, but again, hopefully you can catch it beforehand and see that, hey, these have the same slope, different y-intercept, they're parallel lines, and you can get it from there. Let's see. The last thing I want to show you today is, that didn't work. That didn't work. Is how to do these on the calculator. So your third way to do this is via calculator. If you have a graphing calculator, it works great. If you don't, then I guess you could download one. There's mine's going to work. There it goes. So we do have a graphing calculator here, and we can go back to our original problem here that we already know the answer to. So we're looking at y equals 2x minus 3 and y equals x minus 1. And you can do this on this calculator. It's actually pretty easy, and probably the preferred way to solve these if you have a calculator available to you because it does it for you. So you're going to hit the graph or the y equals button. So here's your blank screen, turn it on, you hit the y equals button, and it brings you to this thing. And you're going to graph both of these lines. So y1 is going to be the first equation, so 2x minus 3. And again, your variable button, this x, I get from this x t theta n button. So be aware of that. So that's the first one. Then we're going to hit the down arrow to move to the second, y equals, and we'll do x minus 1 there. And again, x minus 1. And once you type in, so basically you're going to type in your equations in the y equals window, then you're going to hit the graph button, and it's going to actually draw them. And it looks very similar to the graph that I drew. However, this might be very difficult for you to actually see where they intersect. But your calculator has a tool that does that, and you click second trace, which is your calc button. You can see the yellow calc above it. So we're going to calculate something on this. And you can actually go down to number 5 here, which is the intersect. I want to know where these two lines intersect. So I'm going to click intersect, and then I have to select my first curve, and then I have to select my second curve, and then I got to tell it to calculate it, and it's going to guess where they intersect, and you'll see it. They intersect at this 2, 1 place, which was what our answer was. So it gives you the x coordinate here and the y coordinate there. And this will work for ugly numbers as well, or you can see how it's going to give no solution with our parallel lines. What was our parallel lines? Was that 3x plus 4 and 3x minus 1. You can graph those and you'll see these lines are parallel. Then we get a second calc. I want to intersect. Select both lines, hit guess. It's going to come up with, hey, there is an error because it doesn't exist. There is no answer to that. There is no intersection point between those. So just so you know what it looks like. That's if you have a calculator like this, or you can download this app that I have. But those are the 3 ways to solve them. What I would like you to do is I would like you to look through that page that was assigned. Let me bring it up here. And I don't want to answer questions on it today. I want you to try it first. Right, looking through them, just looking at them like this one here, that's not in y-intercept form. So I'd hold off until tomorrow to do it. Or if you want to sit there and rewrite it in y-intercept form, you're more than welcome to. Over here, not in y-intercept form. So I'd hold off till tomorrow, or you can sit there and rewrite them. This one is probably a good starting point. This one is probably a good starting point. This one, and these ones, and this one. So again, I can't highlight that way in here. It doesn't like that. Look for the ones that are already in y-intercept or slope-intercept form. So it says y equals something, and start with those ones for today. Tomorrow we'll get into how to solve things like this, which really is no different. It's just you have to rewrite one of the equations first. And yeah, you really only have to rewrite one of them, and I'll show you how that works tomorrow. So if there's no further questions for today, give it a shot. Chances are the best way to do these, because a lot of these, this one might be pretty easy for graphing, but you probably want to do it algebraically. We don't need to do all of them by tomorrow. No, you need to do them all by Friday. Again, I'm not going to give you more homework or more assignments tomorrow or Thursday. It's just going to be this page for the week pretty much. I might have something on Friday that I give you depending on how well we're doing on all this. So we can talk then. So with that, I am going to end it and give you a couple minutes to look at that, but I took your 40 minutes. So again, science is all posted and ready, and you're good to go for that. So get that done by the end of the year here, and we'll be all set. So thanks.